Well, we got about 2 minutes to go. Did bring my coffee. Doesn't look like anybody wanted to get up at, well, 7 o'clock Central Standard Time, 8 o'clock Eastern Time. But I'll go through a few resources this morning for those of you that are viewing this later. It's going to be a quick webinar because we don't have any other participants, but wanted to give you guys a rundown of a couple things as far as coding in the curriculum. Um, I know Wisconsin just adopted their own computer science standards, kindergarten through 12th grade. Many high schools are starting to implement around here exploring computer science. There's free training for exploring computer science in our area for teachers that are interested in Wisconsin. Also, code.org. Code.org had a nationwide push for its CS Principles curriculum. The CS Principles curriculum for that training, you could sign up on code.org. I'm not quite sure the application deadlines passed, but they were still taking applications as of about 2-3 days ago. For middle school, most middle schools around the area are, if they're adopting a curriculum for a standalone course, they're using the CS Discoveries or creating their own curriculums around resources and materials within their buildings. Just all depends on if the 6 through 8 is a middle school or if it's a 5 through 8. Depends on the or a K-8. It depends on the configuration of the school. As far as elementary teachers go, we're telling you got to do one more thing. No, just kidding. We kind of are, but if you go about it as a way in which you integrate into the curriculum, it's not so daunting and it can really bring engaging experiences. My forte is really that kindergarten through 8th, although I also help out Marquette University with the whole K through 12 scope and sequence. I worked with MTech to develop a portfolio that's aligned for high school teachers to demonstrate their computer science proficiency because we don't have a lot of teachers in the pipeline. The portfolio will allow them to upload artifacts to demonstrate their knowledge of computer science. So if anybody's interested in that, feel free to shoot me an email at heidi@nofearcoding.org. Talking about no fear coding, this is what helps elementary teachers. So this no fear coding really goes through the integration of computer science and how it's integrated into the curriculum. There's a really great diagram in here. The book is laid out really simply. I used Simon Sinek's The Why, the How, and the What. So for each area, it talks about, there's just 3 simple resources: why you should use it, how you can use it, and exactly what you can do with it. And those resources for our early learners are BBOTs, so kindergarten through 2nd grade. They're really cute little BBOTs that you'll see in the book. You can Google BBOTs. There's lots of YouTube videos of kids using BBOTs. It uses the code.org resources and how you can integrate it into the curriculum with other things that you're teaching and doing. And it also has Scratch in there, which is an open block style of visual coding for students, appropriate from kindergarten all the way up through college. They've used it in some college courses as well. So when you look at a couple pieces that are really useful in the book is Appendix B. So Appendix B is all about the National Council of Mathematics, the math standards, so Common Core math standards. It goes through the mathematical practices, and each one of the practices are outlined in the Appendix B, along with all the bolded words that align to computational thinking and computer science. It also gives some ideas of things that you can do on how to teach it, and it gives a student progression chart of what it looks like as a student progresses in the skill from kindergarten up through 5th grade. So it's a really good addition to the book, is that Appendix B. It also goes through, and there are some explanations in here that talk about project-based learning and inquiry-based learning and the intersection between those, because they do fit rather nicely together. There's a lot of crossover between those. So if you're in a project-based learning environment, or if you're using inquiry-based learning, you'll see where computational thinking fits right in there. So, and I know it might be kind of backwards for you guys, but the lesson plans for this book are actually on my website, nofearcoding.org. So I am going to share my screen with you, and I will show you some resources. So here's my website, nofearcoding.org. One of the things that's highly valuable if you are an administrator is what is your state doing? If you click on what is your state doing, it will take you to a spreadsheet of 9 different policies, and it has all the states listed and what that state is doing. So for example, if you take a look at, this is the overview page. So if you take a look at the state plan, it tells you, does the state have a plan? Yes, no, or is it in progress? Then if you click the tab that says state plan, it gives a little bit more description in the fact that here you have a link to a document where the state plan might be housed. Then you have standards, same thing. It have links in here, whether or not that state has standards. It talks about funding, certification, and what it's required to obtain the certification. Here you'll find significant descriptions from each state on what you would have to do that. It talks about pre-service and what they're doing for teacher training and those people becoming teachers. If there is a state computer science position, it would be listed here, whether it's required in high school. If it counts for a math credit, or in some cases a math and or science or technology credit, that's listed here by state. And then also higher ed entrance. So does that computer science also at high school level also count for potentially college credit? So very useful if you want to know what's happening around the state. And again, that link can be found at the top. What is your state doing? On this website, just gives a little bit of information about me and why I do what I do. I've sectioned off resources so that the resources, if you're a coach or administrator, you can find out more here. And if you're a K-8 teacher, you can find out more here. Then we have signing up for monthly newsletter. I currently have about 1,200 people on my newsletter. Those newsletters go out monthly. I take information that's going on around the state and push it out to teachers. There's always resources for K-5, middle school, and high school in there as well. Then if you do purchase the book makes reference to full lesson plans. So those are here to download, and you can just click on them and they're free. You can download those lesson plans. And then if you want to follow my blog postings also come to my website. I do take the information from those blog postings and put them in the monthly newsletter. So if you have time and don't have time and don't want to worry about going back to a blog, I highlight my most viewed ones on that resource as well. Just to give you an idea about computational thinking. So this one, lemonade stand. It's pretty comprehensive. It can be a great middle school unit or upper elementary unit. It has all the pieces that go with it. So it breaks down the process of computational thinking, starting with the simulation of actually creating a lemonade stand. It has active links. It'll take you to a template form for a presentation for BankQ, because what you're going to do is you're going to play Cool Math, and they're going to play Lemonade Stand, and they're going to track all the data from Lemonade Stand on a spreadsheet in order to be able to create a presentation for BankQ to let them know whether or not they should expand their lemonade stand or maybe even close them down. So when you talk about algorithms and procedures, it can be very time intensive for kids because they have to ask themselves a lot of different questions. And those can be found in the thinking process, can be found in the algorithms and procedures. If you look at the Google Sheet, there is a copy of a Google Sheet in there that will lay out the data and things for them to think about. Then it talks about the automation or the playing of the game, data analysis, and the type of things that you might want to ask them and hopefully have them ask themselves about their presentations, and making graphs and charts for that data representation. It also talks about parallelization, where they're all working on all these different things at the same time, and how do they coordinate that? How do they make that work together? Very business-driven type of model, and great skills for teamwork and collaboration as well. Another resource that you'll find in here, the Hello Grandma and Grandpa, is for our youngest of learners. And the literacy ones that you find in here, many of them will be scaffolded. If it needs to be scaffolded for English language learners with language constructs. So in this case, Hello Grandma and Grandpa is made for kindergarten activity where they send their grandma or grandpa a message. If you see an asterisk on the left-hand side, that means that this is the student worksheet for struggling learners. So you'll see a template form here. So here's what they're going to write, but it puts it into a template form where they're just filling in some names. This would be done more toward the end of kindergarten, or maybe even as a start of the first grade for a project. Here's the regular one, in which they just construct their message to Grandma and Grandpa. They're using 3 blocks in this case. The blocks are very simple. When the green flag is clicked, what is it that I'm going to say? And then I'm going to move toward the heart. And then if you see an asterisk on the right-hand side of the lesson plan, that means it's an advanced lesson plan for those students that need more of a challenge. In this case, if kids are proficient writers, they may end up writing multiple sentences and having the character move multiple times throughout the course of the project. And then we always have the rubrics here, which are aligned to Common Core. So here in their writing, they can use capital letters. They can see a period and say a period when you're asking them to explain their project. They can set their time so the family can read the message, which gets into counting in those math schools. And then another math skill at that level is knowing the longest and the shortest. So defining maybe in the class who has the longest message and who has the shortest message. So those are just a few lesson plans. Scratch is something I would highly recommend. There's lots of student projects out there and things that other students have done where you can just explore what's out there. For example, here's a project, Sri Lanka, that a 3rd grader made. In this case, the classroom was not using Scratch, but this student advocated for herself and said, hey, can I use Scratch to create a presentation rather than just making a PowerPoint like everybody else?
Sri Lanka is an island right next to Asia. Children have lots of fun there. I hope you like my presentation. By Bailey Williams. Colombo is the capital of Sri Lanka. It is located on the west.
So you'll notice, yes, she does have the same last name as me because that was my daughter. So she advocated to be able to do that presentation. Other projects that students have done, one was a short story on shapes. They had a younger sibling who had to identify shapes, and so this child wrote a story to help her sister learn about shapes. So one day the shapes in Geometryville were playing hide and seek. Can you help me find my friends? Just click on them when you see them. How did you find me? Tell me. So is everybody found? Yes. Cute little game. Other ones for a 6th grade project. There was a classroom teacher that worked with an instructional coach, and they implemented Scratch into their language arts class in 6th grade, and they were doing action verbs. So this young lady created a game where they had to drag action verbs. Obviously, that was not an action verb. There we go. Other examples for magnetism and electricity for science. This student created a test review for her kids in her class to review for the test. Not quite sure what's going on there. It looks like the code might be broken for this one. I have to go back and fix that. There's other ones. If you see the numbers here, obviously this is aligned to Common Core, counting cardinality for kindergarten. So simple counting. Now, if I'm a kindergarten teacher, the lesson plan in and of itself, if I see inside, I might be working with students in kindergarten, and not that they have to understand all of this coding, but I might say, you know what, let's go and change our sound of a drum, and let's make it a different sound. Let's make it a tambourine. So you can get the kids involved with picking different sounds to play when you're practicing your counting. Another idea for social studies, kids can create any kind of presentation using coding rather than a format like PowerPoint to code their presentation. In this case, this student created one, and this again was middle school, created one on the Mayan ball game. And at the end of the Mayan ball game, this was an advanced math student. He actually did the programming for, and I'm terrible at this, I'll let you know that now. Actually practice throwing the ball. Almost. But throwing the ball, just like the Mayans did through the hoop. And there are some lessons, again, and this one I believe is a free download on my website as well. But when kids in 4th grade study estimation, it's really hard to estimate off a worksheet. Playing this game, they're asked to estimate the number of bananas on the screen. And you'll notice that it gets progressively harder. The worksheet that goes with this has them look at the variables of how large is my estimate and what's the value of the range of value of acceptable answers for my estimate, how much time is needed for my estimate. So you're looking at different variables as you go through this to see how those variables play in the game and what you have to do when you have a higher number and how that range of value of acceptable answers has to change, as well as how the time has to change for that estimate. So those are just a few examples in Scratch. So hopefully that screen share worked, because I'm not quite sure it did, but hopefully it did. And thank you for viewing.